Good morning, guys. Today we're going to be continuing the topic of inverse functions. Today we're going to be finding the inverse algebraically. Okay, so the notes from last time, we actually finished, at the end of the notes, we were solving for the inverse algebraically, but working only with the linear functions. And so today we're going to look at working with cubic, cube root, square root, and quadratic. And if you remember these are the ones that we graphed. We graphed cubic, we graphed cube root, we graphed square root and quadratic. And so let's read here. Oh, these are the steps actually from the last notes. But there's a little side note before we look at the examples. If we read here, it says, last class we saw that when we found the inverse of a list of points or a table, we did not always have an inverse that was a function. Right? Because remember, to be a function, just to put a side note here, in order to say something as a function, we would say the x values cannot repeat. Okay, so that's what we said last class about being a function. The same principle applies to equations. To make sure our inverses are functions, we must sometimes restrict the domain. So restricting the domain just means that we're going to only look at a certain set of x values. So let me make another note here. When we say restrict the domain, it means that we're only looking at a specific set of x values. And we're going to go more in depth next class when we graph. So restricting the domain makes more sense when we're graphing. But for now, I'm just going to say restricting the domain means only looking at a specific set of x values. So for today, we're going to find the inverse function of a function, and the domain restriction will be given to you. Okay, so for now, the domain restriction is going to be given, and then when we look at next class, when we look at more of the graphing in inverse, then it'll make more sense. Okay, so make sure to include the restriction in your answer. So again, the restriction is going to be given to you, but make sure to include it in the answer. Right, so let's jump into the examples. Right. So it says here to find the inverse function algebraically for each of the following functions. If a domain restriction is given, you must include it in your answer. Okay. The first two don't have a domain restriction, but examples 3 and 4 will have a domain restriction. Okay, and you'll see what that looks like when we get there. So example 1, we have a cubic. We're going to follow kind of the same steps as the last notes. So let's see. So we have, I think I'm going to zoom in again, because we know what we're doing right from the last class. but I just want to make sure I have the space to write. And also you can see what I'm doing, right? So step 1, it says change f of x to y. Step 1, change f of x to y. Okay, so change this one to y. So that's going to look like y equals x to the third plus 5. Okay, so step 1 is done. Step 2, switch x and y. Switch x and y. Step 3, solve for y. Solve for y, so get y by itself. So I need to move the 5, so minus 5 cancels. I get x minus 5 equals y to the third. I need to get rid of the third power. So I'm still solving for, I need to get y by itself, but I need to get rid of the third power. So what's the opposite of raising something to the third power? Is doing the cube root. So whenever you have something that's to the third power and you want to cancel it, you can do the cube root. So when you do the cube root, it cancels the third power. And so my answer becomes y equals the cube root of x minus 5. So I just kind of rewrote this, right? I put y over here, and then the cube root of x minus 5, I put it over here. Okay? And then the last step, step 4, replace y with f inverse of x. Replace this with f inverse of x. So it's going to be f inverse of x equals the cube root of x minus 5. Okay, let's go to example 2. And feel free to pause whenever, so you can kind of copy the notes and you can kind of see where the steps are going. Okay, so I'm going to slide up. Example 2. I'm just going to put 1 and then state the steps. So 1, it says change f of x to y. Change f of x to y. Wait, am I matching the colors? Yes. I want to make sure I'm using the same color. Okay. So if I do that, it's just a simple copy, right? X plus 1. It looks like there's a transformation going on, right? It looks like it's moving. It's a cube root function that's going to move to the left 1 and down 9, right? It's good to kind of remember the transformation rules, right? Step 2, switch X and Y. Switch X and Y. Okay. Step 3, solve for Y. Solve for Y. Get Y by itself. So you have a cube root, you have a plus 1, you have a minus 9. So I like to go from whatever's farthest away from the Y. So let's work with the 9. The minus 9 is the farthest one. So I'm going to do the opposite, right? On both sides, I get x plus 9 equals the cube root of y plus 1. These cancel. And so I'm still wanting to solve for y. Next, before I subtract the 1, I need to get rid of the cube root. But remember in example 1 we said to cancel the power of 3 we use a cube root. So to cancel the cube root we have to raise both sides to the power of 3. Right? So I put the left side in parentheses. The right side in parentheses to the power of 3 and the left side in parentheses to the power of 3. It's going to cancel the power of 3 on the right side. So I'm just going to copy this again. X plus 9 to the third power equals y plus 1. So again, I want to solve for y. I want to get y by itself. One more operation, right? Subtract 1 on both sides. That cancels. So I end up getting y equals x plus 9 to the third minus 1. So again, I switched it up again. I like to have the y first, and then equals, and then x plus 9 to the third, and then the minus 1. Okay, so I'm done with step 3. Step 4, replace y with f inverse of x. Replace y with f inverse of x. So that's going to give me f inverse of x equals x plus 9 to the third power minus 1. And let me fix this arrow here. I don't know if I fixed it, but all right. So hope the color coding helps so we can know what step we're on, right? So the first 2 steps are really easy, or they don't require a lot to do, right? You can see by how many times the color appears. But the green step, solving for y, that's the part that takes a little bit longer, right? And then the purple step, all you're doing is replacing the y with this notation. So the green step is the longest, the third step is the longest. So what skills do you need there, right? You need skills of solving, of doing the opposite operations. Opposite of subtracting is adding. Opposite of a cube root is raising it to the third power. The opposite of adding is subtracting, and so on. All right, let's go to example 3. Okay. Oh, actually, I thought there was less examples, but there's 5 examples. So, and in example 3, we have a restriction. When we find the inverse, we need to make sure to remember to put this notation at the end. Okay, so I'm gonna zoom in, but we're gonna remember about we have to remember about what the note says at the very end. Okay, so step 1, change f of x to y. To switch x and y and then the fun step, right? Solve for y. Okay, so before we can add before we can get rid of the 3, we need to get rid of the square roots. So what's the opposite operation of the square root? Well, the opposite is to put a squared on both sides. So I'm going to have x squared equals, this square on the right is going to cancel with the square root. So it's going to leave me with y plus 3. And so we still need to solve for y. So the opposite of adding is subtracting. So we're going to subtract 3 on both sides. You can't subtract x squared with minus 3, so we're just going to keep them. We're going to copy them and keep them separated. And so we solved for y. And again, I'm just going to switch it over. I'm going to write y equals x squared minus 3. And then step 4, replace replace y with f inverse of x. All right. Oh, and don't forget, right? We have to remember about the note. So let me zoom out and see what was the note in red. It says note inverse function domain restriction. This is a domain restriction. X has to be greater than or equal to 0. So what I mean by domain restriction, number wise, right? If we're looking at all of the x-axis, we're restricting the values to only x values that are greater than or equal to 0. And again, we'll explain it. We'll explain it more, or I'll explain it more when we get to the next lesson, when we talk about graphing. But for now, I'm going to make sure that I take this restriction and put it over here at the end of my solution. So that's x greater than or equal to 0. X. Oh. Okay. Let's go to example 4. And again, let me zoom in. Okay, that's good. Step 1, change f of x to y. So y equals 3x squared. Step 2, switch x and y. Step 3, solve for y. So before we get rid of the square, we want to get rid of the 3. So the opposite of multiplying by 3 is dividing. And so the 3 will cancel over here. And on the left we have x divided by 3 equals y squared. So I'm still solving for y. So I need to get rid of the square. So the opposite of squaring is square root. But I need to square root both sides. So I'm going to copy the left side equals, and the square root and the square cancel, so that leaves me with y. Okay, and again, I like to switch the order so that I have y first and then equals the other side. Now, I don't know if you guys have seen this, but you can also write this fraction, you can also write it in the following way. Okay, so you can, this is the same thing essentially. You can write it as the square root of x divided by 3, or you can write it as the square root of 1 divided by 3 times x. So you can take the 1/3 and put it in front of the x, and it's the same thing. Okay. Step 4 is replace y with f inverse of x. Replace y with f inverse of x. So I'm going to do that over here. I'm going to put f inverse of x equals the square root of 1 divided by 3x. Okay, so for this one, this is my answer. But for this restriction that's here, and again, we'll explain this more, or I'll explain this more when we get to the graphing lesson. But this restriction here is for this function. So just a side note, when we're restricting, the restriction is usually only going to be for the x squared. Just like we did in example 3, like if I scoot up here, we saw example 3. When we solved example 3, we got a quadratic equation, x squared equation, and that equation had a restriction. Now, for example 4, there's a restriction on this function, on the x squared function, but that restriction tells us that we're only looking at a section of the quadratic function. So if x has to be positive, then our square root is going to have a positive, or is going to stay positive. And again, this will make sense when we're graphing, but just think of, if it says x greater than 0, what kind of numbers are those? Those are positive numbers, so that means that my square root answer is going to stay positive. So it's going to make I want to change the color of this notation so we can know. So I'm going to change it to orange. I'm changing the color of the restriction to orange so that we can say, or I can make a note here, that the restriction is greater than 0. So the square root is going to be positive, because x values that are greater than 0 are positive. So the square root is positive. Okay. And then we're going to do one more example, and then I'm going to come back and compare it with example 4. But let me slide down to example 5. Okay. Let's see, step 1. Well, let's try and practice without the steps. See, maybe we've already learned it. So let's try it. I'm just going to circle and change. So it's going to change to a y. We're going to switch the x and the y. We're going to solve for y, to divide both sides by 3. Here I'm going to have 1/3 x equals y squared. I still need to solve for y, so I need to get rid of the square. So square root both sides. And I know what you're probably thinking, right? You're probably saying this is the same equation that we did earlier. And you're right, it is the same actually. But our final answer is going to be different because of the restriction, and I'm going to show you what I mean. And again, this step right here, when I went from here to here, I'm just writing it so that the y is first. And then the last step is replace y with f inverse of x. So I'm going to write f inverse of x equals the square root. Oh, let me leave some space here. Square root of 1/3 x. Okay, so this is my answer. This is my answer. And we have the restriction on the top, up here. But I'm going to change the color, because I'm already using red for another step. Just going to change it to orange. Okay. So when it says here that x has to be less than or equal to 0, then what types of numbers are less than 0? Those are negative numbers. So the square root is going to be negative. So I'm going to put a negative sign here. Negative. Let's compare with example 4. Make sure both of them are in the same screen. There we go. Okay. So in example 4, we solved and we got this answer, or this answer. For example 5, we solved and we got the same answer, because if we look at example 4 and 5, it's the same equation, 3x squared, 3x squared. Okay? The only difference is the restriction. Example 4 says greater than equal to 0, example 5 says less than. So since example 4 said greater than, any number that's greater than 0 is a positive number, so the square root is going to stay positive. In example 5, the restriction is less than 0, so any number that's less than 0 is a negative number. So that means that the square root is going to be negative. So if we actually look at it, the example 4 and 5 have different answers. One of them is positive and the other one is negative. Okay, and you're probably wondering, why do we put a positive on the square root sometimes, and why do we put a negative other times? Well, and I'll leave you with this, but in algebra, if I have, let's say 9, and I square root 9, what's my answer? Well, my answer is either positive or negative 3, actually. Because what is 3 times 3? That's equal to 9. What's negative 3 times negative 3? That's also equal to 9. Right? And 3 times 3 is 3 squared. and negative 3 times negative 3 is negative 3 squared. So again, this example that I'm doing here has nothing to do with the problems. It's just going back to algebra 1. When we square root a number, it's positive and a negative answer. So when we're square rooting here and here, it's possible to have a positive or a negative answer. It just depends on the restriction that they give you. Okay? But again, we can go over this in class, and I can kind of explain it a little bit more there. But thank you for joining me for this video lesson, and I'll see you in class.